Okay, for today, this is a reminder of how to do this kind. And the first thing you do is make it easier on yourself. Sometimes in life, that's the only thing you could do to kind of get through a really tough problem is like try to take one little piece at a time. So let's not even deal with this 2u right away. Let's go change it to sine of u equals -1/2. And we're taking that and replacing it with u. And so we should acknowledge that off to the side. Let 2 theta equal u for just a minute. And do you get how that cleaned up the problem? Now you've seen that one before. Then, this is the part where I need you to find me the two triangles, draw me the two triangles where sine is negative, find me the two answers. Let's say it's 5 pi over 6 and, 8 pi over 6 or whatever it is. Figure out the two answers for sine of u is equal to -1/2. All right, I'm going to actually put you in groups right now so you have somebody to work with, and then I'm going to pause while I do that. Now, see if you can take it from here the whole rest of the way. Can anybody tell me how many answers there will be? There normally be 2 answers, but because of this, you're right. That part, that complication is going to make it so there will be 4 answers to this question. All right, start by finding the two triangles in the right spots here. Then don't forget to swap u back to 2 theta. Don't forget the plus 2 pi k thing. All right, so you should be able to do it, but I know you only learned it yesterday, so this might be a little tough. That's why I give you a partner. Okay, I think I need to start here just to make sure you're on the right track. Sine can't be here and can't be here because sine is negative, and therefore I'm down to these two. Just a quick note, because we're in the chapter called inverses, is this an inverse trig question? No, it's not. There is no little arc in front or the little -1, so this is not inverse trig, and therefore I don't relimit it down to just one spot. There's actually 2 answers, here and here. All right, and then sine is opposite of hypotenuse. 1, 2. Which of those is negative? Only one of them is negative, otherwise it would have canceled and made positive. That one's negative. Okay, and then it's 1, 2, and then square root of 3. That side must be square root of 3, and it's also a negative. It just isn't involved in our sign yet. And then this one must be across from that, but it's a 30, and then that means it's a pi over 6, and that means it's 6 pi over 6 plus 1 more is 7 pi over 6. How many had that as part of your process? I know it's not an answer, actually. It's so weird. You do all that work to find that, and it's not even the answer. That's 7 pi over 6, and then how far do I go? Well, that would have been 12 pi over 6. We have to back off 1 pi over 6 and make it 11 pi over 6. And those are what u is equal to. But remember, we made our life easier by swapping out the 2 theta and the u. Now we got to make our life harder again to finish the job. It's like putting this off until later when we can handle it. Okay, now I'll deal with the fact that u has actually been 2 theta this whole time. 2 theta is 7 pi over 6. And then who remembers what we have to put next? Yes. Plus 2 pi k. What that does for us is it generates the other answers, the ones that are only happening because we're going with a stretch on the inside here. Basically, the answers that makes possible. All right. And so again, if you looked at it as a wave, this is our sine wave going like this. And it's much tighter than it used to be. It used to finish up at like 2 pi. Now it gets 2 cycles in by then. And so you get multiple answers, whereas in the old days you would only had 2. Okay, so then I have to multiply everything. Or sorry, wait a minute. It's 2 theta is equal to this. And then over here I got to make 2 theta equal to 11 pi over 6 plus 2 pi. Okay, and by the way, if I had been using tangent, I wouldn't have used 2 pi. I would have used what? Well, a period of tangent is different. Tangent would have just been pi k, not 2 pi k. All right. And so now, the 7 pi over 6 plus 2 pi k needs to, unfortunately, get more complicated because I have to multiply everything by a half. A half and a half. And that cancels this. Theta is now equal to 7 pi over 12 plus, well, it's 2 pi over 2, which is great, except I want it to be in twelfths. I'm going to let those 2's cancel and just say pi k, but I want it in twelfths. So I'm going to times it by 12 over 12. And it sounds dumb, but it's going to be the fastest to say I'm going to add 12 pi over 12 to find all my other answers. Why over 12? Because these are over 12. All right, so 7 pi over 12 is one of your 4 answers. Raise your hand if you agreed with me that that was one of your 4 answers. Okay, then I got to add how much? It says right there. 12 pi over 12, also known as pi. And if it's 12 and the 7 makes 19 pi over 12, I think. You guys agree with that one? Okay. And the next test you could do is, did that get bigger than 2 pi? Well, really, it comes down to, is 19 twelfths bigger than 2? So no, it's not too big. That worked. Could I try adding another 12 pi? I could. That would make it 31 pi over 12, and that would be more than 2 pi. So better stop. This one. I'm going to multiply everything by a half, and a half, and final answer, theta, is 11 pi over 6 times 2 is 12, plus pi, because the 2's cancel, but I want that to be 12 pi over 12. Then I got these 2 answers from the left side. Now from the right side, I'm going to get 11 pi over 12 for the first one, because if I think of this as k being equal to 0, this first part drops off. And then if I set this k, which was the same as right there, equal to 1, it would be adding one set of 12 pi over 12. So 12 pi over 12 gets added to the 11 pi over 12. 23 pi over 12. There are your 4 answers. Raise your hand if you could have done that. All right, awesome. And you've learned something pretty hardcore. I mean, that is tough. That's tough math. That's right up there with a day of calculus. Because calculus doesn't get any more difficult than that, honestly. I mean, calculus is tough. I'm just saying, a toughest day in pre-calc is a lot like a toughest day in calculus. In fact, a lot of you guys will look back and say, you know, calculus actually felt easy to me compared to pre-calc. Part of it is that we get used to really tough, nasty stuff in here, and then when you go to calculus, this doesn't feel so bad because you've seen it before. But seriously, I've had a lot of kids come back and say, you know what, I felt like calculus was easy compared to pre-calc. I hope that that's the same way it feels for you. I'm not saying AP Calc or IBHL, which is the IB version of Calc, are easy. I'm not saying that. But when it all is over with, the calculus isn't that complicated. It always comes down to the algebra. And like here, that was a whole bunch of algebra we just did that involved fractions. And that's why it's so nasty. All right, so what's new? What do we have to do now that we didn't have to do before? Let's go back a step first and just try to think back to the good old days when life was simple and you had things like that. Would you just solve that equation for me? Because in a moment, it's going to have trig in it. But for right now, we'll just keep it to plain old-fashioned algebra. This should be one of your happy places. You know how to solve quadratics, I hope. I'm going to pause for a second while you solve that. Okay, so I hope this was easy. X plus 1 equals 0. So then, once you've factored it, hopefully you see the answer just sticking right out at like, oh, x plus 1 has to equal 0. And this one's identical, so why do it twice? X must be negative 1. Raise your hand if you had that one right. Okay, awesome. Now imagine for a moment that this was your question. Do you see similarities with what we just did? Do you get what I'm saying? That's essentially the same problem as we just did. And if you can't see it, I'm going to show you by using a U substitution. Let sine of theta be U. And then all of a sudden this becomes u squared plus 2u plus 1 equals 0. And isn't that the same exact thing we just did a second ago? Get what I'm saying? So then you'd solve it by factoring it just like we just did. U plus 1, and then u plus 1 has to equal 0, so u has to equal -1. But if you ever see u in the answer, you can't be done, because you have to swap it back for whatever you substituted in the first place, which was sine of theta. So then do you get sine of theta has to equal -1? Does that look a little bit like the problem you just did a second ago? See what I'm saying? Except, wait a minute, this is a quadrantal, because when you try to draw a triangle, it has sides of 1 and 1, and one of them's a hypotenuse. That's one of those, ooh, I can't draw a triangle. So, remember how this must be one of those quadrantal spots? Finish this one. Remember, you cannot draw triangles, but you can figure out where it is. Maybe it's here. And then sine, remember how sine is y? And remember how those spots, these important spots come up? Like 1, 0, 0, 1, -1, 0, and 0, -1. That's how you do this kind, where you say if sine is the y, which one has a y? Okay, so anyway, finish this off. And a lot of times there's two answers. Not always. With the quadrantals, sometimes you only get one answer. I want to pause for a second while you figure out the answer to the question. Sine of theta equals -1. And of course, the question is, what is theta? I'm going to pause for a second. Let me try this one. Did you figure out that the y would have to be -1? Remember, sine is y. Let's go through those. Sine is y, cosine is x, and what's tangent? Y over x. Okay, good. So, sine is -1 means y is -1, and that's the only spot where y is -1. And so, the answer is 3 pi over 2. Did anybody have a little inkling like, wait a minute, maybe we should call that negative pi over 2? Do you remember that from inverse trig? That inverse trig calls this spot negative pi over 2? How would you pick between those two answers? Well, is this an inverse trig question? Did you ever see a sign with a little -1 on it, or an arc sign in the problem? No. And if there isn't, then you can go back to normal, which is 3 pi over 2. Here's another way you could have answered the question. They'll usually say in the directions that they want the angle to be between 0 and 2 pi. That implies not below 0, right? Bigger than 0, right? Do you get how you shouldn't give a negative answer then? So your answer should be this one, 3 pi over 2. Had it been an inverse trig question, though, they would not have said that, because in inverse trig, you can give negative answers. All the things in this area are negative answers in inverse trig. But this wasn't inverse trig. All right, let's do another one that's similar, but different. That's also a quadratic. It's kind of like x squared minus 1 equals 0. Solve it. I'm going to pause. We'll give that a try. And by the way, somebody's going to ask me, can you do a u substitution? Yeah, you totally can. Do you have to? No, you totally don't have to. You can say, let sine theta equal u, and then you can write it as u squared minus 1. But you don't have to. If you want to write it with sines the whole way, and just say, you know, sine plus 1 and sine minus 1, that kind of stuff, you can. So you can do a u replacement, a u substitution, or not. Either way is okay. So I love this question because it brings in so many little pieces of math, and this is why it's really hard to explain to like counselors and stuff. Why is trig so hard, or why is pre-calc so much harder than just an algebra class? Because you're going to pull in so many pieces of math in this one problem. First of all, you have to notice that this is a quadratic. If we do a u substitution, it's like this. And then you have to know how to factor. If any one of these little pieces breaks down, then you don't get the right answer. Okay, so then that was the second piece of math I had to know, is how to factor. Then I'm going to write u plus 1 equals 0 and u minus 1 equals 0, and therefore u equals negative 1, and therefore u equals positive 1. And then I just did a u substitution. That's a whole different thing. So now I got to remember that u really isn't itself, it's really sine theta. So now I have sine theta equals negative 1, which we just solved that one a second ago. That's kind of cool. I already know the answer for that. But I also have sine theta equals positive 1. That's going to be a different spot, a different quadrantal. So all of a sudden now I have to know a whole different branch of math, which is circle trig. And it's not even a normal circle trig because we're not going to draw triangles. It has to do with quadrantals. You see what I'm saying? Math just jumps around, and you need to know this piece and that piece and the other piece, and you can't afford to have forgotten how to do circle trig or the whole thing's going to be wrong. You can't afford to have forgotten how to factor, otherwise you can't possibly do the question. And in the end, you have to even bring in things like, oh, by the way, is this an inverse trig question? Because if it was, then I would limit myself to only certain quadrants. That's why trig and pre-calc is so hard, because it brings in so many little pieces, and if any one of your base pieces isn't strong, you can't do the question. If you don't know how to do circle trig, you're done. You don't remember what quadrants things are positive and negative in, you're done. So that's one of the reasons I brought the top 20 into this class, because if you can't afford to have weaknesses in like factoring. That's got to be this one of many little pieces you have down. Otherwise, you're stopped. All right, final answers on this one. This is where y was negative 1. Remember, sine is y. That's a whole nother list of things you had to have memorized. Sine is y, cosine's x, and tangent is y over x. So that spot right there was the important one at 0, negative 1. And y is negative 1 right there. And therefore, I need to know that answer, which is how many radians. That's a whole different branch of math, like radians versus degrees. So, and that ended up being 1 pi over 2, 2 pi over 2, 3 pi over 2, 3 pi over 2, one of my answers. And then over here, sine is positive 1. That's where y is positive 1. This is the y-axis. So where is y positive 1? Right there. And that's at 0, 1. And that means that's the only place where y is 1, and that's at pi over 2. Whew! Pi over 2, 3 pi over 2. All right, now that may have seemed doable to you. That's because I made the problem easy. Let's go back to the original problem. The original problem said sine squared minus 1 equals 0. What if the original question said cosine of 2 theta is equal to 0? Then you have to bring in a branch of math called the identities. Now, I'm guessing you haven't got cosine of 2 theta memorized, but somebody will have sine of 2 theta memorized. Sine of 2 theta. Anybody pull up what that one is out of your memory banks? Yes? 2 sine. You're close. That's a good start. Then you have to include a cosine. That's right off the sheet. This is equal to this. Now, I doubt anybody's going to be able to pull up cosine of 2 theta out of their memory banks. Okay, so I'll help you with this one. And you do need to memorize this one. This is not one we're going to tell you for the test, and yet you will need it for the test. So, new one to memorize. They say that on the AP test, this is coming up more often. Sine of 2 theta, having to have that memorized. So you may as well memorize it now. 2 sine cosine. But this is the one that's going to come up on tonight's homework a lot, which is cosine squared minus sine squared. So cosine of 2 theta, you need to know that it is cosine squared minus sine squared. Then, you also, I told you there was only a few that were really important and you should memorize it. Finish this one. Sine squared plus cosine squared What's that equal to? Oh, you guys have got little flaws in the memory banks. It's been a while, I know, and that's why I'm bringing it back, so that it's equal to 1. Good. Okay. So if that's another one you should have memorized, can you replace cosine squared with something? Yeah, what? 1 minus sine squared. Very good. I got to put this, and I've just proven that 1 is equal to 0. So that was only because I set this equal to 0. It wouldn't be set equal to 0. It'd be equal to, let me think. Well, 1, of course. Okay, so what if you see a different problem with cosine 2 theta in it? Whenever you see this, I know you're thinking, wait a minute, didn't we just do a whole bunch of problems where you made us solve things like this and it's equal to, let's say, 1/2? Yeah, you would solve that the way we just started the hour. Let u equal to theta, do circle trig, do the plus 2 pi k thing. You know what I'm talking about? So what's different today, the new stuff for today, says something like this. Is equal to sine squared. Then you have to get it to be a quadratic, which you can then factor and set equal to 0. So again, I don't even need you to solve this question, but my point is, I just told you that you'd have to know this. Can you repeat it right now? What was it? Cosine squared, what? Minus sine squared equals sine squared. Okay, I just brought this down. And I had to know this to be able to replace it with this. Do you get that this is kind of looking like a quadratic because there's a lot of like little u squareds running around if I replace sine squared with u squared? All right. What's the main theme? When this is all over with, you'll end up with something like this. And then you'll be able to factor it. And then once it's factored, you'll be able to set them equal to 0, and then you'll be able to get multiple answers for it. So, know how to factor, check mark. Know that this equals this, have that memorized. Then, know how to do u substitution, where you can make these all into u's and start seeing it as, oh, so u squared and another u squared, and now it's just going to look like a quadratic. And cosine is really 1 minus sine squared, which is 1 minus u, and then all of a sudden that can become a quadratic. All right, let's actually do a problem now. Now that you got the base knowledge, all I was doing there is building up, reminding you how quadratics work, reminding you that sine squared plus cosine squared equals 1, reminding you that cosine of 2 theta was on the sheet and you probably didn't memorize it, but now you need to know it. And what is again cosine of 2 theta? Cosine squared minus sine squared. Okay, good. Now we got all that base. Let's find in the homework where day 2 started. So here we are, day 2. We are getting into the meat, the toughest stuff that you have to know. We have easy chapters coming again. Okay, but this is tough stuff because it pulls on so many things. If you're weak on quadratics, gonna be trouble. If you're weak on circle trig, can't do it. Got to know where all your things are positive and negative. Got to know where you're allowed to be for inverse trig. You know, like, oh, inverse cosine is only allowed here and here. A lot of things to know this chapter. This is a tough one. Okay, so cosine of 2 theta, did I mention you might need to know that? Okay, so what is it again? Cosine squared minus sine squared. And it's equal to cosine. Now, hint, on these problems, You want to get it down to only one function. Since I've got two cosines and one sine, it seems like it'd be a smart idea, to me anyway, to get that sine squared out of there and replace it with something. Remember, that's what identities were all about. Whenever I see sine squared, I can replace it with a lot of other things. Granted, I could make it 1 over cosecant, but that doesn't help at all. What could I put it in so that it would actually be a cosine in there? What could I put in for it? Yes. Yes, 1 minus cosine squared. So this is equal to 1 minus cosine squared. So now I have cosine squared minus parentheses 1 minus cosine squared is equal to cosine. How did that help? Got it down to only one function. Next, if you're going to factor something, there's no point in factoring unless it's set equal to 0. So let's get that cosine over to the other side, and let's distribute out this negative here and see what happens. Okay, so the cosine minus a negative cosine is plus a cosine. That makes 2 cosine squareds. Minus times the 1 makes minus 1 is equal to cosine theta. And I said just a second ago this will be pointless unless we set it equal to 0. So now I'm going to subtract cosine from both sides. And I have 2 cosine squared minus cosine minus 1 equals 0. And at this moment, the people that need to could do a u substitution just to make this simpler and say 2u squared minus u minus 1 equals 0. Because then maybe you'll be able to factor it. If you don't need to do that, you can go ahead and factor it with cosines in it if you want to. But this might help you to let u equal cosine. Then this factors into 2u and u. And it's got to be a minus 1 and a plus 1. I just got to put them in the right spots. There. That's why I spent so much time making sure we were good at factoring on the top 20. And those of you that didn't take the time to do that, now you're done. Because you can't factor this, you won't be able to do the problem. Okay, so now I set 2u plus 1 equal to 0 and u minus 1 equal to 0. Those are the two things that have to equal 0. So 2u equals negative 1, u equals negative 1/2, and then plus 1, u equals 1. There, remember what I said about u? If you have u in your answer, u can't be done. Because u is a substitution, right? What is u really? What did I swap it out for? Right there, I said u is cosine theta. So that's really cosine theta equals negative 1/2. And cosine theta equals 1. And that's 2 circle trig questions. So at the end of 10 minutes of hard work, now I've got it down to 2 circle trig questions. See why circle trig is important? Okay. I know this is tough stuff, but you can handle it. The average grade on this test usually, it's just a little lower than the average grade overall on tests. This isn't that hard, but man, you got to know so much math, but it's kind of cool at the same time because you are using the most math you have ever used in a one problem. It's not just, ooh, I had to do a little area in the middle of my algebra question. This is like, you got to bring in this branch of math and that branch. So many different pieces, and it ends with circle trig. I'm going to finish this one because I've gone this far with it. May as well finish it. This is part of your homework. This is one of your homework questions. Where's cosine negative? Well, cosine's positive here and here, so it can't be there. This was not an inverse cosine question. Otherwise, I would only be allowed to be here and here, but it's not an inverse trig question. So then I got 2 answers. One for this, cosine, adjacent, hypotenuse. One's negative. 1, 2, and this is root 3, and then this is the 60 that's across from that. So therefore, those are pi over 3s, and therefore this is 2 pi over 3. one of my answers. And this one, 3 pi over 3 would be here 4 pi over 3. Oh, it's terrible. There we go. 2 pi over 3 and 4 pi over 3. Over here, cosine is 1. That reminds me, sine was y. What's cosine again? Cosine is the x. Where is x equal to 1? Well, here's the x-axis. That's the spot where x equals 1. So that's the only spot where x equals 1. 1 comma 0. And then what is that spot? It's 0. 2 pi or 0, but usually in the list of like what answers are allowed, they say don't use 2 pi. So therefore we'll default to 0. 0 is one of my angles. 2 pi over 3 and 4 pi over 3. Now that's some high quality math. Very difficult, I know. That was one of your homework problems that I just completed for you, which I think is okay because this is tough stuff. Number 27 is very similar to it. Your first step, you need to have that memorized so you can just slap it right in there. Second step, change everything to sine. Why? Because then, once it's all sine stuff, then you can factor it and set it equal to 0. And then it'll turn out just like what we just did. All right, so I'm assigning 27. These are tough, so I can't assign too many to you. You'll be happy to know. And 25 and 33. I'm going to give you a hint on 33. So there's only 3 questions for tonight's homework. That's a sign of a tough assignment. Do you remember the strategy of change everything to sines and cosines? You're going to want to use that on this problem. So what is tangent really? Sine over cosine. And sine, yeah, that one memorized. I told you a second ago, it's one of the ones on the AP test, so you should probably know it. Nope, that one's the one, that's the one you're thinking of sine squared. This is sine of 2 theta. 2 sine cosine. Memorize that one. You don't have to know that one. Equals, and then tangent is really sine over cosine. The other one you have to know, cosine of 2 theta is cosine squared minus sine squared. Those are the 2 that I'm reminding you were on the sheet, and I did say were probably worth memorizing, but it's easy to forget them because it's been a month at least since we've learned that stuff. Especially, yeah, it's been a long time. All right, so is this one ready to go? Well, kind of, except it's got sines and cosines in it. It would be smarter if we got it down to just 1. At a minimum, we got to get rid of the fraction. We can't stand having a fraction in here. So multiply everything by cosine. And all of a sudden, you'll get a cosine squared. And the cosine squared can be replaced. So it'll be only sines. You should be able to get this down to only sines in it, because the cosine squared that you'll have can be replaced with a 1 minus sine squared. All right, that's a reasonably sized assignment. And I know this was not an easy day, but now it's down to just review. So we'll have a couple days to process. At least at a minimum, tomorrow we'll not have anything new and we'll just have some review tomorrow. And I'm checking with my colleagues to see whether they're testing Thursday or Friday. Earliest you'd possibly test would be Thursday. Okay, that's all I got for you for today.